If light can't escape a black hole, then how did NASA capture a black hole? The Milky Way, our home galaxy, features a supermassive black hole at its heart, and we've never seen it before. The National Science Foundation-funded Event Horizon Telescope has revealed the first photograph of our galaxy's black hole, Sagittarius A. Keep watching to discover more about black holes in Sagittarius A and how the image was captured. But first, let's take a look at how the first photograph of Sagittarius A was acquired and why it's significant. As we already know, a black hole is a point in space with such a powerful gravitational attraction that nothing, still not light, can flee it. The event horizon of a black hole will be the spherical boundary in which the velocity required to escape surpasses the speed of light. As a result, matter and radiation are drawn in, yet they cannot leave. A black hole is genuinely dark. Black holes, regardless of their name, are no empty spaces. A black hole, in reality, has a large amount of mass packed into a compact space. Black holes come in various diameters and can be found everywhere in space. The size of black holes might reveal a lot about their genesis. Scientists understand how certain forms of black holes emerge, while others remain a mystery. Black holes are divided up into three kinds based on their mass: supermassive, intermediate mass, and stellar mass black holes. Stellar mass black holes, which have masses below 100 times that of our Sun, might be found everywhere in our Milky Way galaxy. They are one of the most probable outcomes of a high-mass star's life. Stars are powered by hydrogen fusion, producing helium and other elements deep within their cores. The pressure required to keep the star from shattering under its weight is provided by the outflow of energy from the star's core regions. When the fuel in a high-mass star's core burns up entirely, the star collapses. However, it might sometimes result in a supernova explosion that emits massive amounts of energy detected across the electromagnetic spectrum. A stellar mass black hole potentially arises if the star's mass is more than 25 times that of our Sun. The masses of intermediate mass black holes range from 100 to 100,000 times that of our Sun. The occurrence of intermediate mass black holes have only been speculated until recently. Observing X-rays generated by the gas surrounding a black hole with NASA's Chandra X-ray Observatory has been detected many intermediate black hole candidates. The National Science Foundation funded Laser Interferometer Gravitational Wave Observatory, or LIGO, discovered the collision of two stellar mass black holes with weights of 65 and 85 times that of our Sun, generating an intermediate mass black hole of 142 solar masses. In addition, approximately 9 solar masses were projected away as gravitational waves after some of the mass was performed manually. Supermassive black holes have millions to billions of times the mass of stellar mass black holes. Scientists aren't sure how supermassive black holes develop, but one idea suggests that they emerge when stellar mass black holes collide. Sagittarius A, the black hole in our local galactic center, is a supermassive black hole with a weight of roughly 4 million suns, which is relatively modest for a supermassive black hole. According to NASA's Hubble Space Telescope and other observatories, many galaxies feature supermassive black holes at their centers. Let's take a look at why they're significant. Everyone from young toddlers to experienced astronomers is fascinated with black holes. Learning about Sagittarius A is crucial for astronomers because it gives information on the development of our galaxy and black holes. Understanding the mechanics of black hole generation and growth in their surroundings provides insight into our galaxy's evolution. Sagittarius A is our nearest supermassive black hole, despite being more than 26,000 light-years, or 152 quadrillion miles distant. As galactic matter continues to pass the event horizon, increasing the black hole's mass, its creation and physical processes impact our galaxy. Black hole research also aids in our understanding of how space and time interact. Compared to the flow of time distant from the black hole, time flow decreases when one draws closer. According to Einstein's theory of general relativity, the passage of time slows down near any big object. However, a massive object like a black hole is required to impact the passage of time significantly. There's still a lot to understand about what occurs within a black hole in time and space. So, the more we research them, the more we'll discover. It's past time to learn how scientists pictured Sagittarius A. black holes are undetectable to the naked eye, but their influence on adjacent space and matter might be observed. Black holes have exceptionally high gravity due to their massive mass, which sucks in surrounding material at fast speeds, forcing it to become incredibly hot and radiate X-rays. The material whirling into a black hole may be seen by X-ray detecting observatories, like NASA's Chandra X-ray Observatory, indicating the black hole's location. In addition, the Hubble Space Telescope NASA can detect the speed of gas and stars surrounding a potential black hole in space. Scientists have used these speed data to calculate the black hole's mass. Hubble and Chandra can also see the impacts of gravitational lensing, which is the bending of light caused by the gravitational attraction of black holes and other massive objects like galaxies. The Event Horizon Telescope was built by scientists from all around the world to directly scan the stuff surrounding a black hole, exposing the silhouette of the black hole itself. The Event Horizon Telescope combines the power of several telescopes worldwide that capture radio wave emissions from space to make a virtual telescope the size of Earth. When a team of scientists photographed blazing vapors encircling an M87 galactic black hole roughly 53 million light-years, or 318 quintillion miles, distant from Earth in 2019, they revealed the first image of the black hole's outline. The team then indicated the imaging Sagittarius A would be one of their following goals. The Event Horizon Telescope targeted an array of viewing platforms on the Milky Way's core to make the most recent observation. A telescope array is a collection of telescopes organized to work together as if they were one big telescope. 3 more radio telescopes entered the array to capture the image of Sagittarius A in addition to the telescopes often used to capture the M87 image. Greenland Telescope, Kitt Peak 12-meter telescope in Arizona, and NOEMA, or Northern Extended Millimeter Array in France. The Schwarzschild radius, the distance between the core of Sagittarius A and its event horizon, is immense, measuring 7 million miles of 12 million kilometers, or 0.08 astronomical units. However, because it's so far away, its relative size is small when observed from Earth. Sagittarius A has an assumed Schwarzschild radius of 10 micro-arcseconds, roughly the approximate size of a giant blueberry on the moon. A telescope with excellent resolution, or the capacity to discern the tiniest conceivable features in an image, is required to obtain a good image of a massive object that seems minor when viewed from Earth. The higher the resolution, the better the image, and the more information will be visible. Unfortunately, even the highest resolution individual telescopes or arrays of telescopes at one place are insufficient to image Sagittarius A. Despite being a modest device, the 12-meter Greenland telescope increased the diameter or scope of the Event Horizon Telescope to approximately the diameter of Earth. NOEMA, a network of 12 15-meter antennas with a maximum spacing of 2,500 feet or 760 meters, contributed to the Event Horizon's telescope increased light-gathering capability. The virtual array got a picture of Sagittarius A spanning roughly 50 micro-arcseconds, or around 1/13 of a billion the length of the night sky when integrated into the gigantic Event Horizon Telescope. While the Event Horizon Telescope was engaged in obtaining the spectacular radio picture of Sagittarius A, astronomical observatories worldwide focused on the black hole and the neighborhood around it. What do you fellas think about the black hole? Let's talk about it in the comment section.